And you are host now. So a pretty good turnout. There's 22. Take you and me off. That's 20. That's enough to get started.
Okay. Can everybody see my screen and be able to hear me? It's not a correct English sentence, but you get the gist of it. Okay. Had office hours yesterday. I'm trying to remember the through line. I think the biggest thing I could give advice on is something I've said a couple times. Let's look maybe here. This should work. When you're handed a exercise or whatever, the worst thing you can possibly do is immediately start tacking away at the keyboard. Don't do that. If you can't describe to yourself in English or whichever language you think in what the task it is you're trying to do and the steps to do it, you're going to be in trouble if you immediately start coding. So my advice is to make sure you understand what you're trying to do and can break it down into a couple subtasks before you do. All right. Okay. Today, we're going to be learning something not as interesting or elegant as functions, but just as useful. And that is going to be being able to use files, being able to read and write to files. Trust me when I say you don't want to be manually inputting data to your programs when you're working in data science. The amount of data you're dealing with is going to be in the billions sometimes. So you don't want to have to do that. It would take you a long time. So what's the alternative? Well, one of them is using files, reading and writing to files that already exist that have the stuff we want. Now there's going to be something you need to do a lot for this lab, and that will be find the appropriate file that we're going to be working with, and then save it just like you do the lab, because we're going to need these text files to exist. Because if I don't have my text file, like this, for example, I changed the name to have an extra D, therefore the file does not exist. And I'll go ahead and restart because I tested this earlier. We're going to have a problem. No such file or directory. Also, another thing I remember from office hours, make sure that your lab and your files, the ones that you're wanting to use, are in a, I would say put them in the same folder. Because the kernel that is doing all the work is running in this folder right here. It's where it's expecting stuff to be. Now I can give it stuff from all over my computer if I want. Thing is, I have to use this big giant path. If I just want to be able to say the file name, then everything needs to pretty much be in the same folder. All right. So what are we wanting to do here? Just like I said, before we start tacking away with code, what do we want to do? Well, first thing is we get our file. We want to download it. Now, this file, we can look at it. You can look at text files in Jupyter. You can just double click it. It looks like the following. The first row is 160 and 240, two numbers. And everything beyond that looks kind of like this. The first entry is the row and column count. And the remaining rows are the X, Y, and Z values. The X and Y are spatial locations where the Z values are known. there are 38,400 records in the file. You could manually enter all these if you want, but I don't recommend it. So what we're wanting to do is, first off, what we're wanting to do is mute everybody. All right. Secondly, we're wanting to plot these so that we can visualize it. Okay. Step one. We need to actually have something to hold our data. So we're going to call it the XYZ matrix. Where's our data coming from? Well, it's going to come from this file. How do we get this file open so that we can read from it? Well, what kind of thing is this? So this XYZ file is a variable, and what you can see here, we're calling a function and we're returning something to our variable here. Now this is going to be an object. I can't remember exactly what it is in .NET. It's going to be a string reader. In Python, we'll just call it a connection. So XYZ file is going to be the connection that lets us look at our file. It's not actually the file itself. Consider it a go-between between us and the file. All right, let's try it again with the correct file name. Okay. Now I have an open connection to this file. What's the R stand for? It stands for read mode. All right, let's read the first line. Now, as you can see, this has a couple dots coming off of it. So what order does it go in? Well, it goes from left to right. So take our connection, read the first line, and then do this split function. What's this split function do? Would anybody have an idea what the split function does? Question one actually should be, what kind of thing does this work on? So interesting. You got half of it and not the other half. So yes, it splits whatever I'm working on at blank spaces, the way I'm calling it, yes. But it doesn't work on integers, it works in strings. So you can split a string. And the thing is, how might I want to split a string? Well, maybe I want to split it on commas. Maybe I have a CSV. A CSV is a file type, kind of like a text file. And you've got a whole bunch of data, a whole bunch of numbers split up by commas. Well, how do I split it up by commas? It's pretty simple, really. I give the function the argument. This is known as a delimiter. It's the thing that separates stuff. I give it the delimiters that I want to split with. By default, it is white space. All right, so I'm going to split my line on white space. Okay. And then what am I going to do? I'm going to get my string should now be split into two things. And I'll print it out so you can see what it looks like. And then I'm going to get the row number and the column number. Okay. So when I split a string, I get an array of strings. The first string I was working with was, let's see. It's probably just best to hard code it. Okay. So the string I was working with was 160 space 240. When I called split, it put it into two separate strings, 160 and 240. And now that we have that, I can get the 160 as an integer and the 240 as an integer. All right. So now I have the number of rows and the number of columns. What am I going to do now? For the remaining amount of lines in my connection, what am I going to do here? This is kind of complicated. What the heck is going on? Well, let's read it from inside out. I'm wanting to add something to my list here. What is it I'm wanting to add? Well, I'm going to make a for loop on whatever this is. Now, what might this be? Well, line.strip. Just like we had our line.split, there's also something called strip. Now, I'll tell you right now, the names of these functions are pretty, what is word? They're good, descriptive. They're pretty descriptive. So if I tell you that the strip function works off of a string, what would you think it does? What do we think the strip function does? Well, let's look at the data here. What are some things I might want to get rid of? The strip function is going to get rid of white space for me, just like the split function would split for me. Yes, in this case, it removes spaces. It will remove whatever character I give it. So get rid of white space and then split on comma, just like I was talking about earlier. Instead of splitting on a white space, I want you to split on a comma. Every time you see a comma, split the string up. Okay, so that's what I'm working on, is the line in gridded data that's split up on commas. Okay, so I'm going to get 1, 2, 3 strings in an array or list. And that's what I'm going to iterate over. And what am I going to do with the element? I'm going to turn it into a float. All right. And then I append that to my matrix. All right. So let's do that. Now, every time you open a connection, you should close it. Python's generally pretty good about protecting you from doing silly things, but it's always a good idea, once you know you're done with the connection, to close it. All right, so I'm going to close it. All right, let's take a look at what our matrix looks like now. XYZ matrix, Xyz. All right, it looks like this. Whole bunch of stuff. It is a list containing a bunch of lists. What's the first list? X value, Y value, Z value. What's the second list? X value, Y value, Z value. All right. So now what we're wanting to do is we want to get those, I'll bring it back. I have X values here. So I've got -3, -2.975. I want those values. I want the Y values, and I want the Z values. But it's kind of a little difficult because I have XYZ, XYZ, XYZ. What I want is all the X's, all the Y's, and all the Z's. Now, let's build X list, Y list, and Z list from doing that. What are we going to do here? Well, I want my X list to be a list of lists. What's the inside list going to be? It's going to be a whole bunch of zeros for everything in the range from our row number to column number. So what are we doing here? Can anyone describe what they think this code is doing? If I were to say X for X in XYZ matrix, I'll even make it easier. If I say, give me the number 1 for every X in XYZ matrix, what does this line of code do? I'll even make it easier. Range 0 to 100. what does this particular line right here do? Give back 0 to 99. Well, you're close. Someone says X isn't defined. That is not true. You need to really understand that when you have a for loop, this is a for loop. The X variable is defined as whatever thing we're looking at in our iterable. So I'll make this smaller and I'll put it up here. X is not defined up above, but the moment we get inside the loop, X is whatever the current thing in the iterable is. Now, what I had earlier was X for X in range. Now, that's kind of a strange syntax. It's the same thing as what I have here. For X in range of whatever, print X. But then I changed it to this, print 1. So if this gives me, if print X gives me this, what is print 1 going to give me? It will give you 10 ones. Yes, that is correct. That is very correct. So if this is the same as saying this, 1 for X in range of whatever, then what is this? What I have highlighted, what if 1 for X in range 0 to 10, what is 0 for J in range column? A 0 for every column. That is correct. Now, I'm going to, yes, it prints 0 as many columns there are. Yes. Now, what I'm going to do is I'm going to move what I have highlighted very slightly. I only included those brackets. So what's the difference between what I just had highlighted and what I have highlighted now? What I had highlighted before was a 0 for every column. Well, let's look at it this way. Jackson is correct. Parth, I'm not quite sure what you're saying. So I don't need to go on with my example because you got it. This is a 0 for every column. By surrounding it with the syntax for making a list, all I'm saying is now I want a list that has a 0 for every column. Okay. Now let's treat this, the thing I have highlighted, which is a list containing zeros for every column, as X. Now this code looks very similar. What does this say? X for I in range of row num. Well, I'll make it I so that it's consistent. Just like we said, J in range of column, that was something for every column. Now we're saying something for every row. So you put it all together, and what we have is a row of zeros, or not a row, a list of zeros for every column, and do that for every row. It's almost like we're building a matrix to hold stuff. Let's see what they look like. Print X list. That's a bunch of zeros. And as you may be able to see, it is a list of lists. And what do those inner lists hold? A whole bunch of zeros. So we are building 2D structures for our contour plot. Okay. So now we have a whole bunch of placeholders full of zeros. Now what do we want to do? Well, we want to do an operation on everything that's inside. But since it's a list of lists, we have to have a nested loop structure. Next, instead of having zeros everywhere, I want to get the actual data. Now, does anybody remember where the data is stored for what I'm wanting to do? We filled it up from our file and we put it somewhere. Does anybody remember what variable we put it in? We put it into this XYZ matrix. The thing is, what does the XYZ matrix look like? Well, it's a matrix, two-dimensional. So I need to go from my X list. I want the value at the current pointer in the 0 position because that's where the X is. The X data is here. The Y data is here. It's the second part. And the Z data is here. That's the third part. So counting from 0, we have the first part, the second part, and the third part. So what are we doing here? For 0 to the amount of rows, for 0 to the amount of columns, my X value, row column, is pointer, first part. My Y value is row column, pointer, second part. Z, third part. Now what's the pointer? It's simply saying that, okay, yeah, I'll show this. The pointer is saying, start here. Okay, did you do it? All right, move to here. Let's say I want, my pointer is gonna be here and I want the Z value. Well, how do I get it? Here's position 0, here's position 1, and here's position 2. So pointer, position 2 gets me the Z value. And I'm gonna do that for everything. Last thing we do is we increment the pointer so that it goes up. Alrighty. So filled up our lists. And here I will mention something that I had some trouble with. This is the original code, and I had an error when I tried to run it. Some people might not. This is the fix that I came up with. All right, so we run it. And what do we get? We get a contour plot. Now, what is a contour plot? You have positions X and Y, and the Z value is the in and out of the what you're supposed to be visualizing here. So here on the left, we have things going up to 1.5 of the line, and on the right, we have things going down. So you could view this here as a hill and this as a, we wouldn't call it a valley, but a depression. So this is up and this is down. Okay. So that was a lot, but file input output can be, I wouldn't say it's tricky, it's just tedious. So before I move on to the next example, does anybody have any questions over what we've just gone through? Okay, then either everybody understands perfectly, no one's paying attention, or some other stuff. When you get mine, you just get, when you run yours, you just get errors. When you say you run yours, what do you mean? You talking about this cell here? Okay, try changing the top 2 lines as I just pasted. And while you do that, I'm going to tinker around and see if I can make this look different. Let's try this. Hey, that looks cool. What else can we do? Okay, yeah, that hopefully should fix things. All right, let's look at our next example. As you may have guessed, we're not done with the treasure maps. Could I mention what the strip and split does? I did. and it should be back there in detail for the recording. But strip simply takes a string and gets rid of whatever I put here in the parameter list. By default, it gets rid of white space. And split does the same thing, except instead of getting rid of, it turns a string into multiple strings. They're pretty descriptive, which is nice. Okay. As you may have guessed, we're not done with treasure maps. So what we're going to do, you need this file right here. It will look like this. Looks like a treasure map. And what we're going to do is be able to import a treasure map to our program so that we can now say, instead of a hard-coded treasure map, just give me a file. Okay, what are we going to do here? Well, let's make an empty treasure map so we can hold what we want to hold. Let's make a connection to the file that's going to have it. And then what are we going to do? Well, just like before, let's read this from the inside out. I got a for loop going through my lines in my file. What am I going to do? I'm going to get rid of white space and I'm going to split on commas. Okay, now that I've done that, let's force it as a string just in case. And then what do? I want to slap all that into a list and append that list to my treasure map. And then I'm going to close my connection. And just so we can see what's going on here, I'm going to print out treasure map. And as you can see, you got the first element contains the column names, and then everything else has a row name and then the actual values. Okay. You may notice that the C1, C2, C4, whatever, and the R2, R3, R5, they're not exactly useful. Doesn't have any data for us. All it does is tell us the name of the column and they never change. So let's get rid of those. I'm going to get rid of the entire first row. And then for the remaining rows, I want to get rid of the first part. Okay, let's see what it looks like now. All right, that is the same thing, except we don't have the redundant labels. I don't know if I call them redundant. All right, now what are we going to do? Well, this looks familiar, doesn't it? Can someone tell me what this code does? It finds treasure. I'm going to be very particularly pedantic right now and say almost. In order for you to find treasure, what do you need? Assuming the treasure exists, what do you need in order to find it? Yes, you need a map. So I would say that this code, given a map, finds the treasure. Why was I so pedantic like that? Well, it's because, well, experience for one, and two, yesterday during my office hours, I noticed that knowing where the data you're working on is located and what kind of thing it is a very important thing to keep track of. But that was still a technically correct answer, so that's the best kind of correct. And yep, we're getting close to the point where students no longer understand Futurama references, which is sad. If I have time, I will show it at the end of lab. Okay. So I've got code that does all of the work for me. Why do I have code that does all the work for me? Because this was a homework from previous. Right. So we found that the cell 5-2 contains treasure. Okay, that's what it says. The only thing this doesn't have is a, so it takes an input for the treasure map. I would say it would probably want to take a starting position too, but it has one hard coded, so it's no big deal. All right. Consider a new treasure map located here. So instead of treasure 1, we have treasure 2. They are slightly different. Modify the program to use this map and find all the treasures. There's more than one. Okay. So when we're modifying code, that generally means that we're going to be using it. Okay, so I need 2 more. Put that here. And put this here. All right, I will do some. Well, no, let's do the whole thing together. All right, I got my code copied. What do I need to change? Are we done? Does it work? It's weird that it blurs out the bottle. Treasure 1.txt to treasure 2. Yep, that's definitely something we should change. Yep. Are we done? Well, I'll even go further. Are we done with this block of code? Okay, we say yes. All right, works for me. What about here? Do we need to change anything here? This block of code gets rid of the row labels and the column labels. Do we need to change anything about it? No? Okay, I can live with that. All right. What about here? This is the treasure finding code. Do we need to change anything here? No? Okay. Interesting. Did we get what we wanted? Yes, we needed to keep looking. So if we want something to keep looking, that's kind of like saying, hey, when you stopped before, don't. So where in this code do we have something that says, I found something, now stop? Break? Okay. There are 2. So which one should we look at? Found equals true. Okay. All right. So this is saying if my row from my map is equal to the next one and my column from my map is equal to the next one, we're at a treasure cell. Okay. Found equal true. Break, pass. So what should I change here so that it doesn't stop looking? One of these 3 lines, at least one of them, needs to change. There's a couple ways to do this. What should I do? There's actually a line in this block of code that exits the search when we find the first treasure. It's commented that way, which is good. Descriptive comments are good. And that is the line that is causing the problem. So someone says break, question mark, remove the break. Okay, we'll try it, see what happens. Now, when this is something I went over in lab also, when you're messing around with code in the sense that you don't know if you're going to want it back or not, generally it's better to comment something out than it is to delete it, because you may delete 30,000 lines. You don't want to do that. All right, let's try it. Okay, look at that. Cell 483 contains treasure, 51 contains treasure, 54 contains treasure. Okay. Interesting. So 4-3, row 4, column 3. Or yeah, row 4, column 3. Yep, that looks like a treasure cell to me. What about 5-1, row 5, column 1? Seems correct to me. Row 5, column 4. Yeah, I did say 2 treasures, but looks like there's 3. So by removing the break, what did we do? Well, we said when you find something, no longer stop. The only thing that this gives us a little strange quirk is that we still say there's no treasure found. I would stick around to mess with that to make it not do that, but I want to get to writing, and we've got only a couple minutes left. All right, so we've read from files a bunch. Let us now write. Here is a file, another one. It looks like this. Some text and some text. What are we going to do with it? Well, we're going to read a text file and count how many occurrences of the letter A and the letter M. Then we want to write the result back onto the file. The test case is here. Interesting. I'm curious that this was written here when I ran it earlier. I wonder if it adds on to itself. Yep, it does. That's funny. As you can see. So what does this program do? It looks at text and tells us how many A's are in there and how many M's are in there. Okay, well, in this text, there's 4. Well, how many A's and M's are in this text? There's more. And so every time I run the program, more get added. So I'm just going to delete those so that we don't have to deal with that. Okay, so I just described what the code did. Let's look at the lines that make it work. I'm making a function here. What's this function going to take as an parameter? Well, we're going to call it the in file. We're going to open that file in read mode, get all the data, and then we're going to run through everything in the data. If the letter is a capital A or a lowercase a, increment the count of A by 1. Same thing for M. Now close the file. So we've counted the number of A's and the number of M's. Now what we're going to do is we're going to reopen the file. Why would we close the file and then reopen it? Well, an argument to the open function is a mode. Here we're opening the file in read mode. Here we're opening the file in append mode, meaning I would like to add on to whatever's in the file. And what am I going to write? I'm going to write the number of A's and I'm going to write the number of M's. And then I'm going to close my connection. And that's what my function does. So when I call my function, I say, give me a file name. And then I call the function. And now I've reset my file to what it normally is when you download it. So let's run it, see what happens. Okay, enter the file name and extension. It is writing_file.txt. There are 4 A's and 2 M's. And as we can see, if I refresh it, that information is now written into the file. If I were to run it again, we've added more A's and M's, so it'll tell me there's more. Okay, any questions on that? Mine does not add to the file when it runs. Are you sure? Did you close the file and reopen it? You might be able to have a refresh. I don't know where it is though. Because the only way that would be true, well, there's more than one way. But you see this here, when I say open in append mode, that is literally what it means, is add on to the file. So if it's not adding onto the file after you've refreshed it, something has gone wrong. So if you would do that and let me know if it still doesn't do it, then we can work with that. In the meantime, okay, cool. We have an exercise. We've used text editing to type. After saving it in whatever file we want to call it, you realize that we wrongly typed capital J instead of capital I everywhere. We want to write a function that replaces J's to I's. Okay. This is just a note saying that there is a, you could do this without writing code. You could just do the Control H trick. But we're trying to get some practice in. Okay. Here we're going to make a file. What's the file going to be? I'm going to open a file in write mode. It's W. And I'm going to call it words.txt. What am I going to put there? I'm going to put the following text. And then I'm going to close. So as you can see, there is no words.txt in my bay here. Now I run the code, and now there is. And what we're wanting to do is write some code that will change every uppercase J to an uppercase I. So we already have our scaffolding telling us what we need to do in English. So how do I do it? How do I read from a file? Does anybody know? .read. Interesting. Is that what we did before? Is that how we read from a file? We want to open a connection in read mode. Okay. You can do that. I'll call it my connection. And I want to open a file. What file? Well, it's always going to be called the same thing. So I don't have to worry about taking input. And I want to open it in read mode. Okay, I can do that. Now I have the connection open. What do I want to do with this file? What do I get? Now we can use the read, the .read. And my connection. Now, the big tip I'll give you is when you've done something like this, it's probably a good idea to print it out, see what it looks like. Okay, let's do that. And always remember to close your connection. Okay, when I printed out data, this is what I got. Is this the data that I'm supposed to be working on? Yes, okay, that means that part is done. Now we need to define a function to replace J with an I. I generally like my function definitions to be in a different section, either above or below the rest of my code. So let's define a function. We need the define keyword. I need a name. Well, we've already been told what to name it, so let's name it that, J to I. All right, need a colon. Red val equals, I don't know, 0. Return red val. And here you have a generic function Who knows what it does? It's just a function definition. Now let's change to do what we want. All right, so our J to I function, what do you think it should work on? Does it take an input? It works on a string? Okay. We could do that. We could do that. Call the string S. What do I want to do with this string? Replace J with I? Yes, indeed. How do we do that? Dot replace? Maybe. Let's look that up. Python place. It replaces a specified phrase with another specified phrase. Okay. So S is our input. S dot replace. What should I put as my arguments here? J. Okay. All right. What am I replacing it with? I. Okay. And we're going to return S. Okay. So here's what I'll do. I'll print my data and then I'll print, oops. And then I'll print calling my function. Do we need to replace lower and uppercase? That's a very good question. I'm glad you asked. Are there any lowercase j's in my file? Nope. What I would do is handle both. But because we're only dealing with capitals, we can just do this. Yeah, I left it that way intentionally, so good thing you caught it. All right, let's print that out, see what it looks like. Kind of didn't do what I thought it was going to do, did it? What, well, we're a little over time, so here's what I will do. I'm going to look at the homework real quick, and then we'll come back. What's the homework going to be? Well, exercise 0. Consider the object below name definition. All right, consider it considered. We want to write it into a file and then open and take a screen cap. Put it into the markdown cell here. So you're going to make an image, put it here, and then render it. Okay. Exercise 1. This will generate a file. Read the contents line by line and print each line as it's read. Okay. And just like we did before, we're going to build a script to read this file. I didn't download it on purpose. And you're going to be replacing any occurrence of these phrases with a new phrase. So this phrase gets replaced with this phrase gets replaced with this phrase, so on and so forth. Exercise 3, we're going to get a table that contains data that looks like this. Build a script that reads the data, then captures from the first row the 2 columns to be passed to the plot function below. And you're going to get a plot, and it will look visual and stuff. All right. So let's look here. What might be going wrong here? No. What's our best friend when it comes to figuring that out? It's a print statement. So let's print S. Say S looks like this. Okay. All right. So looks like our replace function is not doing exactly what we thought it would do. So let's look and see how it example. So we have a string. We say the new string should be the replace of the old string. All right. I can do that. Recta equals this. Okay. That looks better. So the only thing left here would be to write it. And we have an example right here of how to write. And what do we want to write to it? Well, external file dot write our new result. And then what do? We always close our connection. Let me just copy it. Alrighty. Let's look at our words. Looks good now. I'll run this one. What does words look like? A problem. I run our fix it code. What does words look like? Looks fine. Okay. So that's the lab and homework. Does anybody have any questions? Granted, most people left, which is fine. But okay, well, there's an exam Friday, so we won't have a lab. And the grading for up to last Wednesday will be up, and I'll have Friday by Friday. So could I go over the last question from the last homework? Sure, I can try at least. So when you say last homework, do you mean 6? Okay. Exercise 3. Modify the wrapper script above to create a plot using the following. Okay. Label the plot and the plot axes. All right. Well, I'm going to pretend that I have a wrapper script that does all the work. Okay. Because that's not the point of exercise 3. That's the point of like exercise 2 and stuff. So what's the point of exercise 3? Well, I need to define a function. And it's going to take t as an argument. And it's going to turn something. And I need to define another function, y func t. And it's going to return, oops, something. What's the something? It's 16 sine squared t. How do I return a function that's just 16t, 16 times t? Could you give me how would I write a function that is f of x equals 16x? Assign a variable to 16t and return the variable. Not sure I follow. So this f of x equals x. What if I wanted it to be, okay, 16 times t? Pretty simple. So now I have a function that gives me 16 times t. Cool, got it. Is that what's going on here? Almost. So there's 3 things here. There's 16, there's sine, and there's cubed. So I will do each of those. And there's also a subtraction, but I'm pretty sure you can figure that part out. Okay, so here's the multiplication part. What about third power? How do I do f of x equals 16t to the third power? How do I do that? like this. Brackets. I'm assuming you mean parentheses, which I agree with. I like parentheses. Okay, cool. What about this? How do I make that work? It kind of depends on what you're going for. I want 16 times t, the whole thing, third power, and sine from math. Okay, sounds like you've gotten pretty far. Import math. Okay, and then I want to do math.sine on all of this. All right, that's everything. I've just done each little bit, and I intentionally didn't put it together. This is not correct for x of t. I intentionally made it different, so don't copy this, but do use the methods we just used. So that's how we do the function. The last thing is, how do I get the right steps? Well, let's make a loop for x in something. And x. The angle value. Okay, well, let's work on something. How do I make a list of numbers, integers, from, let's say, 0 to 10, without hard coding it? For loop? Yep, I'm in a for loop. Yes, I am. But I need to make the list. There's a function we've been using inside of for loops quite a bit. Starts with an R. Yes, range. So I'm going to go from 0 to 2 times pi. Now, slight problem here. What's pi? Well, it turns out math has a pi. I believe it's uppercase. Let's see. Yeah, sorry. Python doesn't like those parentheses. Okay. Is it lowercase? Float cannot be integered. So what we do now is, what do you mean, yes, this? I don't get how to deal with this float and range thingy. Well, I almost gave you the answer. Now I'm not gonna. What's going on here? Well, range works on 2 integers. And I'm handing it a integer and a float, because pi is 3.14159, blah, 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 blah. And what's 2 times pi? Well, it's going to be 6.4 something. 6.28, blah, blah. Okay. Well, that's not an integer, is it? How might I make an integer out of it? Not sure. That's fine. We have a method that would cast it to an integer, and it would give you 6. The thing is, you don't need to do that. Just do that. Now here's the thing. I just turned 6.28 into 6. And then I just print out the value. Now, obviously, I'm leaving a lot out here. And I'm going to have to go. But Dr. Cleveland just linked you a good page. What I want you to think about is, I've given you the solution to getting rid of that error. But what you need to think about is, and this no longer goes to 2 pi. So there's a third argument here, which is the step. I'd like you to think about how I can mess around with this step going from 0 to 2 pi to get this to look a little nicer. But I do have to go. It is 10:07. You can always email me, and good luck on the exam. Thank you.